All right, so looking at the next little method of factoring here. I know last class we talked about the difference of squares. Today we're going to talk about the other method you would use possibly when you have just two terms, which is this method, the sum and difference of cubes. So it's when we have some perfect cube numbers that are either added or subtracted from another perfect cube number. So perfect cube right there, you can see, is a number that you get by multiplying it by itself 3 times. So there, you can see listed here on the right of the equal sign are all the perfect cube numbers. Just listed out for you to 1 to 15. So this is a good little list to refer to. I don't really expect you to memorize all these. Maybe try to memorize this first column, the one that these will appear probably the most. But you can also figure those out just by, in your calculator, taking 1 times 1 times 1, 2 times 2 times 2, and so forth, 5 times 5 times 5, to see what perfect cubes would look like. So we're going to flip it over and talk about how you would factor when you have this sum and difference of cubes. So flipping, right, so looking at it, 8 is one of those numbers. Next page here, we have a little diagram. I'm just showing you what it would look like for sum and difference of cubes. Here, you're going to break it down based on these A and B values, and that's kind of the pattern that you're going to follow. So as you look at this pattern, just notice that in the pattern, these things are the same or in the same order. Only thing that changes here is the operations between the two, right? So looking at it, we have A and B in the first set of parentheses, A squared to start the second parentheses, A times B as the second term there, and then lastly we end up with a B squared. So notice that there, the only thing different between the sum of cubes and the difference of cubes really is just the signs that come in between. And so you can see here that for sum of cubes we start with addition, for difference of cubes we start with subtraction. And next, right, these signs are opposite, last sign will be the same. So really all we're going to do is memorize this acronym to help us remember what these signs are that go, or what are the operations that go in each of these parentheses. So here you can see the acronym that you're going to remember. SOAP, S stands for the same sign, O for the opposite sign, and then the last one is always positive. So all we're going to do is find A and B by taking the cube roots of each of these terms. So if they're perfect cubes, which one of the giveaways here that you have perfect cubes, right, would be an exponent of 3 on the variable. Then you would just want to check your number here, 8, to make sure that there's a number you can multiply by itself 3 times to get 8. So looking at it, all we need to do here is take the cube root, of each of these terms. So we're taking the cube root now of each term to figure out A and B. So we'll do this one. So the cube root of x to the third ends up just being x. So in this case, our A value is just going to be x. The B value we get from taking the cube root of 8, which in this case was 2. So now that we know the A and B values, we can start to set up our parentheses. So I like to just go ahead and set up the parentheses right away, making sure that we have 2 terms in the first, 3 terms in the second, and then fill out the signs using the acronyms. Remember, the acronym is same sign, opposite sign, always positive. So looking at the original problem, right, this original problem was a subtraction problem, x to the third minus 8, so we're going to use that same sign that appeared originally, or a subtraction sign. Next sign we're going to use is the opposite sign. So if we started with subtraction, next one opposite would be addition. And then the last one here is always positive, or always addition. So filling it in now, this first set of parentheses, we're just going to have, just like up above you can see, right, we have the A and B values now. So we're just going to put them in places of that A and B. So the first one is just A first, B second. So this first parentheses just ends up being x minus 2. Now over here, as you can see up above, the second set of parentheses, you want to start out with your A value squared, or multiply times itself. So if our A value is x, squaring it, we would end up with x squared. I jump to the end typically, just because these are both kind of alike to me. So like I would first do this first term, square my a value, then I jump to the end and square my b value. So 2 squared would be 4. So I like to just do those both on either side of that second set of parentheses. And then in the middle, recognizing that here we're taking a times b. So in this case, x times 2 would give us 2x. Then we are done, right? So like that process, as long as we can memorize this, what goes in each set of parentheses, and that acronym SOAP, the sum and difference of cubes is not quite as scary as it may seem, right? So let's try another one here. Look at number 2. Find your a and b values. So taking the cube root here of b to the third, our a value comes out to be b. Taking the cube root of 27, our b value, this is kind of confusing since we had b as one of our variables, but here our b value would end up being 3, right? So looking at the first set of parentheses, remember you can create your parentheses and immediately go put all of your signs in there. So the same sign would be addition, opposite sign, subtraction, last sign, always positive. So now we just put the b in the 3, those 2 values that we got in the first set of parentheses. Next, we're going to square the values and put them in the beginning and end. So taking the first one, b and squaring it would get b squared. Taking the 3 and squaring it, 3 times 3 would give us 9. Remember, in the middle, you're just going to take the 2 values you found from cube rooting those numbers and multiply them together. So b times 3 would just give us 3b. So that is all you need to do here to factor using that sum and difference of cubes method. So we'll start to go through just a couple more of these. Let's look at this next one. Here, taking the cube root of x to the third, you would just get x as your a value. Taking the cube root of 64, our b value would then just end up being 4. Since 4 times 4 times 4 gets us 64. And then once again, now we can set up our parentheses. So remember, any sum or difference of cubes, we're going to have 2 terms in the first parentheses, 3 terms in the second set of parentheses. So same sign comes first, then our opposite sign, and then the last one's always positive using that SOAP acronym. So now we just need to plug in those a and b values that we found in the first set of parentheses, square them to get the values in the first and third term in that second set of parentheses. So x squared and 16. So 16 we just got by squaring the 4 times 4. And then in the middle, we multiply the 2 together to get 4x. Taking a look here at this next one. A to the third plus 25. So taking the cube root here, we get a for that first value. Taking the cube root here, we would get 5 for that second value. So all we're going to do here, create our parentheses again. Same sign, opposite sign, always positive. So it's helpful to put the letters up there just to recognize why we're putting those values there. So same sign just means you're always going to use whatever sign originally appears in the problem, right? So in this case, since we had an addition sign, we're putting an addition sign. And then opposite would just be the opposite of the original problem. So if the original problem was addition, opposite would be subtraction. So now just taking the a and the 5, plugging it in this first set of parentheses. Next, to start out, we're going to square the a to get a squared. At the end, we're going to square the 5 to get 25. And then in the middle, we're multiplying those 2 things we found together to get 5a. So that's just kind of the order that makes the most sense to me. Here, you don't have to do it in that order. You can just go straight across from left to right, and we'll try that here with this next one. So taking the cube root here of each of these terms, cube root of 27x. Here you're just going to take the cube root of 27, which is 3. The cube root of x to the third would just be x. So here that first value that we're going to use as our a value would be 3x. Looking at 64, taking the cube root of that, we would get 4. So remember the first step, just cube root each of those perfect cubes. Setting up our parentheses again. Looking at the signs, same, opposite, always positive. we'll end up with addition, subtraction, then addition. So now just plugging in the 3x and the 4 into the first set of parentheses. And this time we'll just work from left to right. So this first one we get by taking the a value and squaring it. So in this case, we had 3x as the a value. So 3x times 3x ends up being 9x squared. Now moving to the middle term there, remember you're going to take those two values, multiply them together, the a and b values you found. So 3x times 4 ends up being 12x. And then lastly, taking your b value and squaring it, 4 times 4 would end up being 16. So that is just quick little examples of how you would use your sum and difference of cubes methods to go ahead and factor those things out. So looking at it, we've talked about this before, but remember, we've talked about the flow chart as far as how to factor, right? You always start with the GCF, but then you're going to look at how many terms. If there's 4 terms, you're going to try to factor by grouping. If there's 3 terms, right, initially, you're still looking for the GCF. If a value is 1, you can go straight into the parentheses with the values you find in your X method. If their a value does not equal 1, you're going to want to take the factors that you found and then split it up into 4 terms, then factor by grouping. And then lastly, if there's 2 terms, we've talked about now, difference of squares, and then now sum and difference of cubes. So just going back through that flow chart as you look at it. So you can now just use the remaining time here to work on the delta math and the assignment.